This thing looks like a diode laser and a spaceship had a baby. Before I get into the specifics of the laser, let's throw some material on here, and I want you to take a look and see if you can guess what's going on with this laser. So what I'm going to do is I'm just going to throw the material I have on and use just their information. I want to test it as is right out of the box. First up, let's throw a slate coaster in. So slate coaster using the settings directly from the manual, no tweaking, nothing like that. Looks pretty darn good. I didn't sand this, I didn't coat this. If I had done those things, I could have made the white stand out more, but this again was just out of the box testing. Next up, aluminum business card. The aluminum business card, not bad. It's not 100% consistent, but part of that can be because, I don't know if you'll be able to see it from the side, this card has a little bit of a twist to it, and that happened while it was running. The laser actually heats up the metal and causes it to warp, and when it warps, it defocuses, because these type of lasers do have an issue with going out of focus very easily. So that probably explains why it's not completely consistent, but even so, pretty darn good right out of the box. Blue acrylic. This is the acrylic. This one's a little light for my liking, and it sort of fades in and out, but this is a pretty flat piece of plastic. Even so, there's probably defects in manufacturing, which means it's going to go out of focus a little bit as the laser's running. Overall, not bad though. Chunk of aluminum. So this is the owl that I engraved on this chunk of aluminum, and metal is what makes this laser different, because this is actually down into the metal. This is not a surface marking. I've actually engraved down into the metal. So before we move on to the other metals that I engraved, let's talk about the laser real quick. So this is the Atomstack A20 Pro fiber laser. It's a 20-watt fiber laser. I have a link down in the description if you want to learn more about this laser. It's not a diode laser. I know it looks kind of like a diode laser, except for the spaceship looking module here. And the cool thing about it being on open frame is you can do larger areas. Please excuse my dirty honeycomb. I really need to clean that. You can do 400 by 400. On my galvo fiber laser, I only have 220 by 220 max. There are some drawbacks to the fiber laser. For example, this thing has to be super in focus for it to be efficient. If this is even out of focus a little bit, you're going to lose efficiency, and the engraving and or cutting will not work. This becomes an issue when you have a very large piece of material that is not perfectly flat. For example, I have this large piece of steel here. It's just some, I believe this is just some mild steel. And if I were to engrave this entire thing, because it's not flat, you can see it's not laying flat, it is wobbling, you're going to get variations. In fact, I'll show you in just a little bit. I'm going to engrave something on this. So this did come with assembly needed, but not much. I have to say, as I'm getting older, I really enjoy a piece of equipment that comes fully assembled or mostly assembled, because I just want to get to using the thing. Speaking of getting older, you know what's weird is they say as you get older, you care less about things, which is true, but they don't tell you you start to care about strange stuff as you get older. For example, why did I wake up the other day and suddenly had 14 apps on my phone to identify birds? Like, yeah, birds are cool. I've seen birds before. I like looking at birds, but I never cared about what kind of bird was sitting on my fence until recently. You would think I'm preparing for the day that people take my family hostage and say, unless you can identify this bird, you'll never see your family again. Which, depending on the day, I might just be like, it's a giraffe. Also, this bird definitely does not live near my house. So on the laser, we've got a control box on the frame itself, and then we've got this giant box over here. So let's go over this part first. Obviously, this is your standard setup for a diode laser, open frame diode laser, except it has a linear bearing rail for the x-axis, which is a nice upgrade, because typically there's still the V-groove rollers like this, which will wear out over time and give you a little bit of slop. This is not a diode laser module. No, this is actually a lens for a fiber laser. This is a fiber laser, and this is just the lens. You can see this yellow cord coming out here. This is the fiber optic cable. If we trace that back, it goes all the way over into the control box here. So this is the laser source, It's generated in the box. It's fired down the fiber on the lens module and then down onto your workpiece. And that's basically it. The other slight difference is that this has a frequency control for the frequency of the laser. This goes from 30 to 60. Back on the box, I don't know about the screen. I haven't tested that. It has a USB drive, so you can run it right from the USB. It has an autofocus button, but that doesn't actually do anything, because in order to autofocus, this would have to be an electric up and down, and it's not. It is a manual. Now, it is nice. It does have a fine tunable up and down, and that's how you focus the laser. See, I've got 2 spots down here, and what we do is we slowly adjust the dial up and down until they basically become as close to one spot as possible. This did have some assembly required, but I have to say, for an assembly required laser, this had pretty minimal amounts. For example, the rails with the Y carriage on it, these are pre-assembled. I didn't have to stretch belts, I didn't have to do any of that. Both of these were pre-assembled, and then the X-axis was pre-assembled. I basically had to put the 4 pieces on the outside together, put the X beam on, hook up a couple wires, and that was it. So pretty straightforward. One drawback is that it only comes with this manual. The manual has instructions, but the problem is the pictures can be a little hard to interpret in some places. And so, I mean, I got something backwards once and had to redo it. No big deal. But I would really prefer if it had come with like a video instructions on how to assemble it, so you can really see. Most of the higher end diode lasers these days that need assembly come with a video to explain it. Stainless steel business card. Stainless steel business card. We have a little bit of coloration. It's a little bit lighter over here. And again, I think if you look at the side, it's got a little bit of a twist to it from heating while it was being engraved, and that's going to cause the laser to go out of focus. And just like the aluminum, this is actually has depth to it. This isn't just a surface marking, this is actually engraving down into the stainless steel. Piece of steel. Giant piece of metal here. I don't know if you can make out the words, but it says, "What is the airspeed velocity of an unladen swallow?" Leave me a comment and let me know what movies that's from. Bonus points if you can quote the whole scene. You can see it's got some darkness to it, and this is basically, this is engraved. Like, I can feel the depth with my fingertip here, and basically the darkness is an oxide layer that has formed as the laser ran. So not bad. The nice thing about this is this piece of steel is 360 millimeters, which is bigger than I can do on my galvo fiber laser. So that sort of demonstrates the ability of this laser, which has a 400 by 400 working area. Because I know people are going to ask, clear acrylic. Sadly, this cannot do clear acrylic either. You might have seen it sparking a little bit while I was running, as basically probably picking up some dust, debris, and or maybe the backing paper was catching. So it will not engrave acrylic, and if it won't engrave, it definitely won't cut. And wood. This is 3mm basswood ply. The wood. Nothing. Zip, zilch, nada. This type of laser does not do well with wood. It won't engrave, and if it won't engrave, it definitely won't cut. So if you want to work with wood, unfortunately, this laser will not do it. You will have to have either a diode or CO2 to do wood engraving and cutting. Now, the book does have cutting parameters, so let's try cutting a 0.2mm aluminum business card. Well, that did not quite work out. And I actually tested this several more times with different colors. Well, actually just one different color. And same issue. In fact, this one I did multiple passes, and because the cards warp so much, it takes it out of focus, and it actually ends up, it's not even cutting in the same spot at that point. Because this is the thinnest metal I had that the book said I could cut through, this is the only test I was able to do with cutting. And unfortunately, it didn't work. To be fair, these are coated aluminum cards, so maybe that has something to do with it. I don't know for sure. but I was not able to get the machine to cut through the aluminum. So can this replace your diode laser? Not really, because I know a very common material is wood, and you cannot even engrave wood with this laser. You would still need a CO2 or a diode laser to engrave and cut the wood. And if you want to do clear acrylic, even a diode laser is not going to work for that. You will need a CO2 laser. But if you want to do some metal engraving or etching on a large scale, I think this laser makes sense, as long as you can find material that's going to stay flat enough and won't warp and take that laser out of focus during the engraving process. Thanks for watching, everybody.